The next directions, the next type of equations that we are going to solve, we have to be careful about because there are restrictions on the variable. For instance, the directions say, write the value or values of the variable that makes the denominator equal 0. These are the restrictions on the variable. Keeping the restrictions in mind, solve the equation. So basically what you're going to do is you're going to look at your denominators. They have variables in there. So what would make x equal 0 in the first part of number 32 is if x was 0. Because if I substituted in for 5x and I put a 0 in there, 0 would be in the denominator of a fraction. That is not allowed in math. That is undefined. So when I'm looking for an answer, I'm going to keep in mind that 0 cannot be an answer. So x will never be 0 in this problem. If it comes up to be 0, I'm going to have to say that my answer is undefined or no solution. All right, so that was the first denominator. Let's look at the second denominator that has a fraction in it. The second denominator is 3x, so let's think about that. If I let 3x equal 0, let's solve for x. I'm going to divide both sides by 3. So 0 divided by 3 is 0. So again, x comes up to be 0. So in reality, I only have one restriction on the variable. I'm going to solve this problem, and I'm going to keep in mind that I can have any answer in the world except 0. So how do I go about figuring out how to solve this equation? Well, I'm going to look at my denominators. My denominator is x and 3x. Remember that we're looking for the first multiplication facts that x and 3x have in common. So my GCF here is going to be 3x. So I'm going to multiply 3x by every term. Whether it is a fraction or whether it's not a fraction. What we're doing here is we're using a very basic principle in math, that as long as I multiply one side of the equation by something and I multiply that other side of the equation by the exact same thing, that equation maintains its balance. So let's see what happens. The x's are going to cancel out in the first example. 3 times 5 is 15. This 3x is going to cancel out with that 3x, and I'm left with 10. And then 3x times 4, this leaves me with 12x. If I want to solve for x, I'm going to take everything that doesn't have my variable to the other side by doing the opposite. 15 minus 10 is 5. I get 5 equals 12x. Solving for x, if I'm multiplying by 12, I'm going to do the opposite and divide by 12. So x ends up being 5/12. As long as my answer is not that restriction, it's not 0, then I'm going to be able to use that answer. In other words, 5/12 would be a good answer. As long as that answer was not 0. Had it come out to be 0, we would have to say no solution. All right, so let's look at another example. This time, I've got a denominator of x plus 4. This is an expression. If you want to, you can put parentheses around that. So I have one denominator, that is x plus 4. So let's look at the restriction on the variable. What would make x plus 4 equal 0? Well, if I solved for that and I subtracted 4 from both sides, if x was negative 4, then my denominator would be 0. Look at the first fraction, 3, x plus 4. If I let x be negative 4 in that parentheses, negative 4 plus 4 is 0. So again, I have 0 in the denominator, which we've already stated is undefined. So my restriction on the variable in this problem is going to be negative 4. So when I'm solving that, I'm keeping that in mind, that I can have any answer but negative 4. So how do I solve it? I'm going to go about solving it the same exact way. I'm going to change my color to blue here. This will be different than the original problem. All right, I have one denominator, that is x plus 4. So x plus 4 is my common denominator. My least common multiple, in other words. So I'm going to multiply every term by this x plus 4. Even this minus 7, even if it isn't a fraction, it doesn't matter. Every term has to be multiplied by that common denominator. So this x plus 4 is going to cancel out with that expression. I get 3. I'm going to distribute the negative 7. The x plus 4's cancel out. I'm left with negative 4. Adding positive 3 and negative 28, I get negative 25. I'm going to take the minus 25 to the other side, doing the opposite. So I get negative 7x equals positive 21. So I get an answer of negative 3. As long as that answer was not my restriction, then I'm going to be able to use that answer. So x is negative 3. All right, when we look at 44, I see that I have 3 different denominators. So when I'm looking for the restrictions, I need to, first of all, make sure that all of my problems are factored. So what I'm going to do is I'm going to start by rewriting the problem. X plus 3 cannot be factored. But if I look at the denominator, 2x plus 6, it has a GCF. Don't forget about the number 1 rule of factoring. Now, once it's factored, my common factor is going to be x minus 2 times x plus 3 times 2. That is listing all the factors that we have here. Now, let's look at the restrictions on the variable. Restrictions would be anything that makes any of those denominators equal 0. So what would make x plus 3 equal 0? Well, if I subtract 3, if x was negative 3, that would make my first denominator equal 0. So that's going to be a restriction. X can never be negative 3. All right, the next part is 2x plus 6, or 2 times x plus 3. And you can either set 2x plus 6 equal to 0, or you can think about it this way. It's 2 times x plus 3, so I set 2 equal to 0. That will never equal 0. So basically, that will not be any restrictions there. The second part of that was x plus 3, which we've already solved. That would be negative 3. So we already knew negative 3 could not be an answer. The last denominator is x minus 2. So if we see the restriction there, we would set it equal to 0. And when solving for x, we see that if x was equal to 2, it would make this denominator equal 0. And so that would not be allowed. So I have 2 restrictions on the variable here. X cannot be negative 3, and x cannot be positive 2. So keeping that in mind, I'm going to go through and I'm going to solve. So I'm going to multiply every term by this long denominator, or least common multiple. Those are my restrictions. I'm going to put them over there. So, x plus 3 is going to cancel out with x plus 3. I am left with 2 times x minus 2 times 3. Remember, when we multiply, it doesn't matter in what order I multiply. So I could say 2 times 3 is 6. And then 6 times x minus 2. All right, look in the second example. On the other side of the equals, the x plus 3 is going to cancel out. This 2 cancels out with that 2. And I'm left with 5 times x minus 2. And the last part, the x minus 2's cancel out. 1 times anything is that same number. So just taking it step by step. I'm going to go through and I'm going to distribute. Combine like terms. So 5x and 2x, we get 7x. Negative 10 and a positive 6, we get negative 4. To keep my variable positive, and I don't have to do that, but I'm going to move the 6x over to the other side. So negative 12. That's what I get when I cancel out the minus 6x. 7x minus 6x gives me 1. And I get x minus 4. I'm going to add 4 to both sides. And I get x equals negative 8. All right, since negative 8 is not negative 3 or negative 2, this is a good answer. And I'm going to be able to use negative 8. Again, the restrictions on the variable mean that these answers that I've gotten, if plugged into the denominator, would make them 0, would make my answer undefined or my fraction undefined, and I'm not allowed to do that. All right, let's work one more example of this type. And these should be six over x plus 3 minus 5 over x minus 2 is negative 20 over x squared plus x minus 6. So I want to look for the restrictions on the variable, but I notice that I have a trinomial over there on the right side. So what's going to happen there is I'm actually going to be able to factor that problem. When we're pulling out and trying to multiply by the common denominator, I need to make sure everything is factored. So this is one of those easy trinomials that we talked about in the first section. That's why we reviewed the factoring. Trinomial did not have a GCF, so I have 2 sets of parentheses. My third term is negative, so that's plus minus. X squared breaks down into x times x. And 2 numbers that multiply together to give me this negative 6, but add together to give me this positive 1 that's in front of there would be a positive 3 and negative 2. So just a heads up, in a lot of problems like this, they are rigged. So if you see an x plus 3 and an x minus 2 over here, more than likely, your signs should be the same. So my GCF in this problem, or least common multiple, is those binomials, x plus 3 times x minus 2. So what I'm going to do is I'm going to take, and I'm multiplying every term by that common denominator, which I'm writing in red. So this x plus 3 will cancel out with that x plus 3. And I'm left with 6 times x minus 2. The x minus 2's are going to cancel out. I'm left with a negative 5 times x plus 3. And on the right side, it looked like it was going to be bad, but all of those cancel out. and I'm just left with a negative 20. So I'm going to go through and distribute, being careful on the second part to distribute a negative 5. So 6x and a negative 5x is x. Negative 12 plus negative 15 is negative 27. I'm going to add 27 to both sides. And I get x equals 7. Since 7 was not one of my restrictions, which we should have talked about, if I set all of those denominators equal to 0, my restrictions would have been x equals 2 and x equals negative 3. So any answer is good except those. Since 7 is not 2 or negative 3, then I could keep that as an answer. Be careful when working some of these, because you will come up to a point where one of your answers ends up being a negative 3, and you're going to have to throw that answer out. All right, look at the next type of problem. It says find all values of x such that y equals 0, and it gives me what y1 is equal to, what y2 is equal to, and it asks me to solve y1 equals y2. So all we're really doing here is substitution. We have y1 equals y2, and we're going to replace y1 with what y1 equals to. This did not convert the best in the world. This is 5 times 2x minus 8 minus 2. And we're going to set equal to it what y2 is equal to, which is 5 multiplied times x minus 3 plus 3. So let's distribute. 10x minus 40. A minus 40 and a minus 2 added together is a negative 42. We have 5x minus 15 plus 3. Adding negative 15 and plus 5, I get negative 12. Subtracting 5x from both sides, 5x minus 42 equals negative 12. All right, we're going to add 42 to both sides. So we get 5x equals 30. Divide both sides by 5. Your answer comes up to be 6. So all you have to do on these is look at what they're asking you. Most of the time it'll say y1 equals y2. It might even say y1 plus y2. Then you would just add them together. If it said y1 minus y2, you would subtract them. Just be careful if you were subtracting. Remember, anytime you have a subtraction in front of an expression, you need to use parentheses. Okay? The directions for 57 is a little bit different, and it says find all values of x satisfying the given equation, and it also tells me that y equals 0. I don't have a y1 and a y2 here, but it tells me that y equals 0. So what I'm really doing is I'm substituting wherever I see y. I'm substituting it in for 0. So basically you're setting the equation equal to 0. So let's clean up inside these first brackets. I have x. I'm going to distribute. Negative times 3 is negative 3. Negative times negative is positive x. And if I distribute here, negative 7 times x is negative 7. Negative 7 times 1 is negative 7. So let's add our like terms. Both of these x's are positive, so that's like saying 1x plus 1x. That's 2x minus 3. Again, I'm just cleaning up this right side. So 0 equals 8x minus 12. Still just cleaning up, so I'm going to move over here. 8x and a negative 7x. That's going to give me positive x. Negative 12 and negative 7 is negative 19. And then if I solve for x, I'm going to add 19 to both sides. So x is 19. We don't have to worry about restrictions in a problem like this because there are no denominators. It's okay to have 0 in the numerator. It's not okay to have 0 in the denominator. All right, so the next part is we're going to categorize an equation. It says solve each equation and determine whether it is an identity, a conditional, or an inconsistent. Let's start off talking about the thing that it tells us to do first, and that is to solve each equation. So the easiest one is a conditional equation. A conditional equation I can solve. An identity equation has an infinite number of solutions. An inconsistent equation has no solution. And I can solve. It has an answer and it has 1 or 2 answers. It's not going to have infinite. So all you do to figure out how we classify an equation is try to solve it. So let's try to solve 61. On the right side, let's distribute. (9x) and a minus 4x gives me 5x. When I stop right here, I see that the left side is identical to the right side. This actually represents an identity equation. Whatever number I plug in for x would make both the left and the right side equal. But a way that you can continue to solve and know that it's an identity is if I was trying to solve, I would subtract 5x from both sides. When your variables cancel out and the statement that you're left with is true, this means it's an identity equation. Go back up to here. Every answer that I plug in for the right side would also be an answer for the left side. For instance, if I had 5x plus 9 equals 5x plus 9, every number, if I plugged in 1 for x, it would always give me a true statement because they're identical statements on both sides. If I plugged in 2, I'm going to get 19 on both sides. No matter what number I plug in for x, there are infinite solutions. Every value of x would make this equation true. The left side would always equal the right side. But if you'll remember that when you're solving, if your x's cancel out and the statement is true, it's going to be an identity equation. Let's look at 63. Let's try to solve it. Distributing. Now I'm going to get the x's on the same side. In this case, the variable cancels out, but the remaining statement is not true. This is going to be a situation where this does not have a solution. There's no number that I could plug in for x that would ever make the left side equal the right side. This is what we consider an inconsistent equation. So when your variables cancel out, the statement is not true. We have an inconsistent, basically an equation with no solution. I want to work one more that will show you an example of a conditional equation. And I didn't add this into your notes, so I'm just going to pull one. If I was given this example and I was asked if it was a conditional, an inconsistent, or an identity, I would try to solve it. 7x equals 77. Divide both sides by 7. X was 11. Knowing that it's solvable and I get an answer, this is what we call a conditional equation. So, an identity has an infinite number of solutions. Your variables will cancel out, and the remaining statement will be true. An inconsistent equation has no solution. Your variables will cancel out, and the remaining statement is not true. And the other kind is if the equation is solvable and you can come up with some answers, it is a conditional equation.